All right, welcome to this video, which is Production Possibilities, Frontiers, and Opportunity Cost. So in here, we're going to analyze a graph of how much we can produce of two things. And so we're going to look at the trade-off between those two. And obviously, that trade-off is going to be the opportunity cost. And we're going to look at it in a graphical and mathematical way. Okay, so let's begin. All right, so a production possibilities frontier is the maximum combination of production that is attainable. So it's the maximum combination of production that is attainable. Okay, so for example, let's suppose that you are a consultant for BMW. And BMW has two things it can produce. It can produce its Sportster, the Z4, or it can produce its SUV, which is the X5. So they have their X5, which is their SUV, or they have their Sportster, the Z4. And they want to know, well, how much should we produce of each? And what happens if we want to produce another Sportster? What do we have to give up in return? So they only have a certain amount of vehicles that they can produce a week, and if they're making Sportsters, that means that they can't be using that equipment to make SUVs. So there's a trade-off involved, okay? And as a consultant, you're going to help BMW analyze what are the choices and what are some of the costs or the trade-offs that they face if they want to produce a different type of vehicle, okay? So for BMW, we have a few different choices. Okay, so we have choice A, B, C, D, or E. Okay, and this is going to be the number of Z4s, which is the Sportster. And then here is going to be the X5, which is their SUV. Okay, so choice A says that every week they can spend all their time and resources producing Z4s only. So if they spent all their time producing Z4s or their Sportsters, they could produce 400 in a week. However, if they spent all their time producing Sportsters, that means that they don't have any time to produce SUVs. So the number of SUVs would be 0. Okay? The second choice, suppose point B, they could produce 300 Z4s. And if they did that, so they produced 100 less, that means that they have some time left over to produce SUVs. And with that time, they can produce 100. Excuse me, 200. Choice 3 involves producing even less Z4s, so going down by another 100. And if they went down by another 100, suppose that they can produce 200 more X5s or SUVs, so they can produce 400. Choice D would be 100 and 600. And then choice E is going to be if they spent all of their time producing SUVs only. So choice E would be 0 and 800. Okay? So as a consultant for BMW, they want to know which choice should we produce at and why. Or suppose that they're already producing at choice C and you have to help them analyze, should they produce at choice B, choice D? What are the costs involved with changing points? Okay, so the first thing that we're going to look at here is going to be a graph of this relationship. Okay, so we have a lot of information in this table, and we want to make it into a simple form, or we're going to use a graph to help us. Okay, excuse me. So here we're going to have number of SUVs. So here's our SUVs, the X5, and here's our Sportster, the Z4. Okay, and we have 800, 600, 400, 200, 100, 200, 300, 400. Okay, so then we're just going to go and graph our choices. So we have A, which is 0 SUVs, but 400 Sportsters. So this is choice A. Choice B, which is 300 and 200. C, D, and E. Okay, and then what we're going to do is we're just going to draw a line through here. Okay, so we have A, B, C, D, or E. Okay, so here's our graph of our production possibilities frontier. Okay, so here is a maximum combination that we can produce in a week of Sportsters and SUVs. So anywhere along this line is something that's attainable for BMW. Okay, and then lastly, for simplicity's sake, we're going to say, or let's say we have a point F and a point G. Okay, so now that we have our production possibilities frontier in a graph, we can delete our table. Okay, and in this case, we know that A, B, C, D, or E are going to be attainable. What about point F? So F, well, if we can produce 200 and 400, we can obviously produce 100 and 400, right? So F is attainable, but we know that we can produce more SUVs or more Sportsters in a week, right? We can move to C or D if we were at point F and produce more vehicles in a week without giving up on another one. So we could produce more in the same amount of time. So F is productively inefficient. So F is attainable, but inefficient. Okay, what about point G? Well, if the maximum amount that we can produce is 400 SUVs and 400 and 200, then obviously we can't produce 400 and 400. Okay, so point G is unattainable. Okay, so if we're looking at efficient points that are actually attainable, the only efficient and attainable points are going to be along this line. Okay, so our production possibilities frontier shows us the region that's attainable, this line or inward, versus the region that's unattainable, which is outside of the line. But the only efficient points are going to be along this line. So first of all, you're telling BMW that they can produce any of these combinations as a consultant, but you would be most efficient if you produced somewhere along this line. Okay, so as a consultant, you would want to maximize BMW's profits by making them the most efficient. So you would have them produce A, B, C, D, or E. Next thing, suppose that we are at point C. So BMW is currently at point C. And they want to know what happens if we want to produce more SUVs. What is the cost of producing more SUVs, or producing one more SUV? Okay, so here they want to produce more SUVs. So they want to move from C to D. And they want to know what are the costs involved there. Okay, so here we want to know our benefit is selling more SUVs. The cost of selling more SUVs or manufacturing more SUVs means that if we're producing more SUVs, we can't produce as many Sportsters. So the cost is forfeiting Sportsters. Okay, so what we really want to know is what is the cost and what are the benefits of producing more SUVs? Okay, or what we want to know is what is the cost of the next best alternative? To produce an SUV, the next best alternative, if BMW wasn't producing our SUV, it would be producing Sportsters. So we're going to be analyzing the opportunity cost. Okay, so the opportunity cost of whatever, here it's SUVs, is going to be what do we lose over what do we gain, equals the cost over the benefit. Okay, and we're thinking marginal cost and marginal benefit here. Okay, so here the marginal cost or the opportunity cost of producing more SUVs means, well, what did they forfeit? They had to forfeit Sportsters. Well, if they're at point C and they move to point D, how many Sportsters do they give up? Well, they were at 200, and then they moved down to 100, so they forfeited 100 Z4s. Okay, so they gave up 100 Z4s over what they gained. And what did they gain? Well, if they were at point C and now they're at point D, they went from 400 to 600 X5s. So they gained 200 X5s. That's a 5. Okay, so here, the opportunity cost of producing one more SUV, if BMW is currently at point C, is they forfeit 100 Z4s to gain 200 X5s, or that comes out to 1/2 Z4 per X5. Or for every additional SUV that BMW makes, they have to give up making 1/2 of a Z4. Okay, so the opportunity cost of an SUV is 1/2 Z4 per every SUV that they make. Okay, so if they made two more SUVs from point C, they would have to forfeit 1 Z4. Okay, so that's the opportunity cost. And here, if we're looking at the opportunity cost of our SUVs, notice how SUVs is on the x-axis. This is change in y over change in x. So our opportunity cost of our SUV, or the x-axis, is simply the slope. Okay, so we're thinking at the margin again, and if we're thinking at the margin, we're using a slope of our graph. So the opportunity cost, which I'm going to abbreviate OC, of our x-axis equals the slope. So here it was the change in y, which is 100, over the change in x, which is 200. 100 over 200, or we can say minus. It's really a minus because it's a cost. We forfeit 100 Z4s to gain 200 X5s, right? So, but since it's a cost, we know it's negative. Okay, so our slope is negative 1/2. Okay, and that's going to tell us the opportunity cost of whatever is on our x-axis. Now, once we know that, we can easily find the opportunity cost of producing another Sportster. So now suppose that BMW is at point D and it wants to shift to point C. So it says that we really need to produce more Z4s. It's summertime and we have a lot of people coming in that want a convertible, which our Z4 is a convertible. So we need to produce more convertibles. Well, to do so, we have to forfeit SUVs. So we're going to analyze how many SUVs do we have to give up to make more Sportsters. And in this case, we could easily find it by taking the reciprocal of what we just did. So notice how if we went from C to D, we gained 200 X5s, but we had to lose 100 Z4s. Now, if we wanted to go from D to C, we would just have to give up. We would go from 600 SUVs to 400 SUVs. So we would forfeit 200 SUVs. Let me see. I'm going to erase this. So the OC of the y-axis equals 1 over the slope. Okay? So the opportunity cost of Z4s, or the Sportster, well, we gave up 600 to 400 SUVs, so we gave up 200 SUVs. So the cost is going to be 200 X5s. And what did we gain? We went from 100 to 200 Sportsters. So BMW is producing 100 more Sportsters, or 100 Z4s. Okay, and we could put a minus there again if we needed. Okay, or the opportunity cost of producing another Sportster for BMW is equal to 2 X5s per Z4. Okay, or the correct way to read this is for BMW to produce one more Sportster, it costs them producing 2 X5s. Okay, so to produce one more Sportster, they have to give up producing 2 SUVs. Okay, so if we have our production possibilities frontier, the slope of it gives us the opportunity cost of our x-axis, and 1 over the slope, 1 divided by 1/2 gives us 2, which gives us the slope opportunity cost of our y-axis. Okay, and opportunity cost is always, always, always measured by what did it cost us divided by what did we gain. So the cost over the gain. Okay, and that's always how we're going to analyze opportunity cost. So if we're thinking of opportunity cost, we're thinking about what do we have to give up compared to what do we gain. Okay, and so that completes our analysis of production possibilities, frontiers, and opportunity cost. But we're going to use opportunity cost in the next one when we look at trade. So we're going to be analyzing opportunity cost and production possibilities frontier, and we're going to compare maybe BMW to Mercedes-Benz. Or we're really going to look at a few other examples, and we're going to see what happens if they each produce the same thing, what would happen, and so forth. So we're going to compare 2 different manufacturers.